Hey everyone, welcome back. So in this video we are going to understand the problem number 3587 from the Leetcode, and this question has been asked in weekly contest 159. Okay, so let's understand what the question statement is saying. That so the question statement is saying that we have given an array nums of distinct integers, right? So as you can see the example, right, what we have given, an array we have given these nums, and each element is distinct, means unique. Okay, so it is also saying in one operation you can swap any two adjacent element, right? Means if you talk about the adjacent, right, operations of the operations, so we have to swap the two element adjacent element in this array to do that, right, in the operations. What is that operations? Further it is saying that an arrangement of array is considered valid, right? You will do how many operations doesn't matter, but one operations only two elements you have to swap. Also saying that will be an arrangement of element in the array. It is considered valid if the parity of adjacent element, right, alternates, meaning every pair of neighboring elements consist of one even and one odd number. If this is the arrangement, it means it is valid. Return the minimum number of adjacent swaps required to transform nums into valid arrangement. Means the given array should be transformed, right? Should be transformed into a valid what? Arrangement. And you know what is the valid arrangement? Valid arrangement is it should be in every pair of neighboring elements consist of one even and one odd, right? It means if we'll talk about the this one, so what we have given? We have given 2, 4, 6, 5 and 7, right? So this is our nums array we have given, right? So if we will apply the very first operations, so the first operation, let's continue to understand as example saying. So we will consider swapping 6 and 5, right? If we'll do swap, right, after swap, you know what we need to do? Each operation we have to do swap of two adjacent elements. So these two are adjacent element. What we will do? So the array will become, after swapping these, what will it become? It will become 2, 4, 5, 6, 7, right? We can consider this. So this is your new array, right? Okay, give me 1 second, it will make confused you. Okay, now think, if we will in the next operation, right, we will do swapping of two elements. In this time we will take these two, right, 5 and 4. Now this time it will become what? 2, 5, 4, 6, 7, correct, right? And in the third operation, if we'll convert, so this time we'll take 6 and 7. What will become? Then 2, 5, 4, 7 and 6, right? Now check, this is even, this is odd, this is even, this is odd, this is even. It means this is a valid arrangement, right? It means we have to transform from where? It means we want to transform from here to this array, right? So in the very first step, what we have done? We have swapped these two element. In this case we will return, we have swapped this 4, 5 here. In this case we have swapped this these two. Yeah, we have done, we have already done, right? And here we have done 7 and 6, right? So all the operations, right, we have done, right? And each operation we have taken only two element to swap. After the transform, you will get the valid arrangement, and that will be our answer. But answer is how many operations you have taken, how many number of adjacent, we have to return number of adjacent swap required to transform, means the number of operations you perform, that you have to return. So right, so total number is 3 we have to return. Understand? I hope you understand, guys, right? So what we have given, in this question we have given here the nums we have given, the operations we have to perform, right? You can swap any adjacent element any number of times, right? So then it is also saying you want to rearrange the array so that the parity alternates, right? Means there should be one odd even pairs should be there, right? And we have to return the minimum number of adjacent swaps required, right? Means number of operations that you going to perform on this array, right? That you have to return. Otherwise we'll return -1, right? If it is impossible to alternate the parity. Okay, so you understand what are the things we have given, right? Now observe the question. You have to observe the question. Means first of all, what we need to understand, what is the alternate parity, right? Alternate parity is there should be even count, right? Sorry, not this. There should be an even count, and there should be another we can say if this is even count equal to odd count. No, you just think if even count is equal to what? Odd count, right? If both count are same, the even count and odd count both are same, right? So their difference, if we'll do the difference, right, even minus odd, so difference will become what? Less than equal to 1. Yes, if you observe anywhere, right? So you will get the difference 1. If you take the difference of this, what at the last we got, which array we got? 2, 5, 4, 7, 6, right? Now count the number of even count and odd count. 1, 2, 3. Total count is 3. Odd count 1, 2, 2. You'll do 2. How many you will get? 1, right? Either you will have 1 or should be less than 1. Understand? So even and odd count should be less than 1. Then you have to understand, you only care about what? Indices of even and odd count, right? Indices, like this is even, so this is even, this is even, like that, and this is odd, right? So what we care? We only care about the indices of even and odd, right? And not their actual value. We want to consider the even and odd count, right? So we should complete the what we can say in such a way, right? So first of all we'll find the even count and odd count. Then we should think while writing the code about the indices of the even and odd count, not the actual value, right? We should also understand what. So first step, second step, these things we have to understand. Third, what you should understand, means if we'll compute the minimum total distance, right, that we have traveled, right, the even and odd should need to move to get the desired alternate arrangement, like this. If we are not coming to this arrangement, like suppose 0, 2, 4 for the alternate position, the even position, and so on, right? Similarly for the odd count, right? So we have to compute the minimum total distance, okay, so that the even and odd, even or odd, should move to get the desired positions, right? So if we will transform directly into a number of swaps, right, that is needed, then we can compute it, right, as we have seen. So let's understand the code now. Okay, so 1 second, what we will do. Okay, so first of all, what we should do, we should find what we have to collect the indices of odd and even, right? In the very first step. Okay, so we'll in the step 1. Yeah, in step 1 what we should do, we should let's collect the indices, right? Indices of even even and odd numbers, right? You can say it means to find the even and odd indices, you should have you can say a container, right? That should contain everything. So we can take a list, right? Array list. Let's take an array list. We can say list, and it will take what? All the integers, right? List of integer, and we can say even indices, right? You can say that ind, we can say. Okay, then then we can say we have to find what, we have to initialize it, right? New array list, you can say that. So even indices, let's complete first. So even indices, and we'll take another what, odd indices, right? Let me copy this and just write here. Okay, so even and odd we will use. Two things we have to initialize. Okay, in the very first step you have to initialize what, odd and even indices count, right? So that we can collect all the odd and even numbers here. Next, what we have given, nums we have given. So from here we can find what is the length of the nums using nums dot length. So if you have the n, you know the number of elements. For the number of elements, we'll traverse all the elements, right? So we can say int I is 0, and we'll go, I should go to what, n less than n, right? I plus plus means index 0 to last index n minus 1. Okay, if condition should be what, if nums at I, means there will be some element, right? We are talking about some element, and it's you can say, if we will do what, if we'll check the parity, if it is coming what, you know, odd and even find, right? You can do using the mod also, right? So if you'll write like this, and we'll say it is equal to 0, right? So the element, if it is coming equal to 0, or you can take mod also, and we'll say it is even number, so you will add on the even, right? What is the even indices, we'll collect here, right? Even indices dot, you will write add, array method, array have a method add, right? And we'll add I here. So we will consider about the indices, right? So we'll use the indices, not the number, actual value, not the actual value, right? That we have already talked. So here we'll add what, even number, right? You can say element number is even, right? So we are doing this one. In the else condition, we'll do the same thing, right? Just will add the odd index, right? And it is for the element is odd, right? Odd, this is odd and this is even. The very first step, we'll do this step, okay? So that we will collect all the indices of even and odd, right? Now understand further. So the first step, we have to collect this one. What is the second step? Step 2 should check if it is impossible to collect the to alternate parity. If alternate parity is coming or not coming, it is it impossible or possible, right? So let's check if it's impossible to alternate parity, or the arrangement is correct or not, right? How are we going to check that? You know how can we find the count, right? Or you can say size. So we can say we have even equal to even indices, right, dot size. We can do that, we can get from here. Similarly, if we'll write odd is equal to, we can get from where? Odd indices dot size. So we'll get these two, right? In this way we will get the odd and even, right? Now we'll check if math dot absolute value, right, ABS. So this is a math function where we can find the absolute difference. You know, we have checked the difference even minus odd, right? We can do that. If even minus odd is greater than, not less than, equal to. If less than equal to means fine, it is possible. We'll check not impossible. If it is impossible, right? So if it is impossible, it means what? We cannot alternate this. It will, if we will return what? Minus 1. Remember, if it is impossible, so we can say it means we cannot alternate if one type is you can say outnumber to other, right, by more than this, right? We cannot alternate the type, one type. Just say we cannot alternate if one type, right, one type outnumber to other by more than one, right? Okay, we cannot alternate. Okay, then what we should do? If it is, let's suppose we can, it is possible, it means it will not go here, correct? It means we will come to the third step. Remember what I told you, the third step, step 3. In step 3 we will check, right? What we will check? Let's first of all we'll find the, we have find the it is possible or not possible. If it is possible, so you should compute the swap cost, right? What is the swap cost? How many swap cost you have done, right? You have to check the pattern, odd even, like that. So there should be you can say we'll create a function that will do these things, right? Just take a utility function and you can do that. So let's compute, we can say let's compute the swap cost based on who start first, right? Means we have to find the count. You know, it can be come, the odd will come first or even will come first. That is the cost, that is the thing can be possible, right? So we'll say if even is greater than odd, it means what? 3 minus 2 we have done, right? So in this case the pattern will be like what? Pattern will be you can say first it will come even, then it will come odd, then it will come even, then it will come odd, right? Like this it will come. I hope you understands. Then we'll return let's suppose a function that will find the count. So we can say we'll create a swap count. This swap count function will return for the event what is the count of this, right? And so we'll return the swap count, right? Then let's suppose in else condition, if let's suppose the odd count is greater than the even one, right? If odd count is greater than the even, right, it means we'll do the swap count, we'll return the swap count, but here we'll pass what? Odd. Here we'll pass odd, like this. Now think if it is equal, right? right? So there can be another condition, it not less than, not greater than, right? It means if both counts are equal, right? And so we will try both starting options and will return what? The minimum. What is the minimum? Minimum. You check the minimum. Okay, just return what? Math dot mean, right? And here we'll pass the count value. What is the count? We'll pass here. So here I will use even count, and here we will use odd count. What is the minimum? Which one is minimum? We will return it. Okay, so now only one thing is required to do. What is the swap count? Let's continue to write this, we can say implement this utility function. So let's come down here, right? So this is after this function we'll write the utility method or helper method, you can say, right? So the method name should be same, swap count, right? And we can write what? Private, it will return integer and the name will remain same, and we'll use the list of index, right? So this odd and even is what? It will come what? Odd and even is, it will take the size, right? It will take. So what we have considered, we will, if you are the swap, so it has already the count, right? It means little bit changes you have to done, right? You have to pass this even, here will pass even, and here will pass odd. Okay, and similarly here will pass even, here will pass odd. Okay, because we have to pass the indices, right? We have to pass the indices, right? Odd and even indices, so that we will find the count, right? So if we'll talk about this indices, so indices we have defined like this. So any of these indices will take from here and will add here like this. It means we want to swap the count, right? But we have to pass the indices. We cannot say even indices. This will become your indices, right? And we can say the indices size we will write here. Okay, we will call this, right? It will return the count, right? So just define a count is equal to 0 and return this count, right? In between that we have to write the logic, right? So what should be the logic? The very first step, right? We want to do what? We want to calculate the minimum adjacent swap, right? And for that you will iterate for all the elements, right? So let's iterate for all the elements. So we'll start from where? Index I equal to 0, because the all the indices will be there, right? So this is nothing but your indices, or indices yes, dot, if we'll do size, what we will get? All the indices. So we are traveling for all the indices, we will traversing for all the indices, and we'll count plus plus, right? We'll do +1 if math dot abs of you can say there should be some value, right? How will get the value? You know, this is a list, right? Indices is a list, so you can do get and you pass the index and you will get the element, right? Then we will do 2 into I. Which one is? It will come you can say absolute value, right? And your absolute value, let's suppose you are at indices 0, right? So you will do what? 0. At 0, what you will get? Some indices you will get, odd and even you will get, right? Let's suppose. So let's suppose we have given indices, right? If we'll talk about these indices, right? So if this indices contains what? Array, sorry, a list of element, and that element is 0, 1, and we'll take another 2, right? If it is 0, 1 and 2, means we have position of even number, right? We are talking about the position of even number, right? So we'll say this is the position of even numbers. Okay, so this is the position of even numbers, right? So we want to place them at a position what? 0, 2 and 4 to the alternate with the odds, correct? What are the alternates will be there? Alternates. And so we can say alternates position, right? Let me write down here, right? So alternate position will be what? It will be 0, 2 and 4. Just think, and you can write with yourself. Okay, so this will be the odd positions that we need to compute, right? We have to find this, we have to compute it, right? How we are going to do this, right? Let's suppose I is initially it was what? 0, right? 0, 1, 2 we have. So I is 0. In that case, what will happen? I'm just explaining you the things so you have to understand. Okay, let's suppose I will take a multi-line comment and we'll say like this. Okay, so when I is equal to 0, right, what will happen? You will take math dot absolute value here, right? These things. So math dot abs, let's suppose I'll take this math dot abs, right? So this math dot abs will pass what? The indices get at I, what will come? It will come 0, correct? Then we'll pass what? Minus 2 into I, right? So I is 0. So once you will multiply 2 into I, it will also come what? 0, right? So we'll say math dot 0 dot 0, 0 minus 0. What you will get? You will get 0, right? Then think, if let's suppose I'll copy this, two things will occur, right? When I equal to 1, it means indices dot get, you will get what? You will get 1. But when you multiply 2 into I, what you will get? 2. What is the absolute value? 1. Now think, if it is I equal to, this time it is 2. So when you do math dot absolute value, you will pass what? 2. It will become what? 4. 2 into I equal to 4, and so it will become what? 2. Understand? So if we will do total swap, right, you know the total swap if we'll do, so total swap, it will become what? That is required, that is needed, right? You do the sum, what? 0 plus 1 plus 2, these numbers, how many? 3, and you have to return this 3. Okay, so this is the thing I'm doing here. Okay, I hope you understand. So once you have the count, what you need to do? So once you have the count, you just need to return this count, right? You will not do anything, just return the count, right? So let's continue. Let's run the code. Okay, submit this. Accepted. Okay, so that's all I have today, guys. If you have any doubt, please ping me in the comment box, and please write that space and time complexity in the code, so I will understand that you have followed and you understand the code. If you have any doubt, you can ask me about the time complexity, anything. Please write the code and let me know. Thank you for watching this video.